Hi, for this video, still learning um, sigma notation. This is part 2, right? So on the previous video, we've learned a couple of things. Recap, please check out previous video, but I'll just show you here. We've learned that sum of n term is the same as n, the same as this thing. This is your general term. It can be not limited to, actually can be your arithmetic term. This is the arithmetic term that we know. Can be your geometric term. This is a geometric term we know, equal to Rn minus 1, etc. Right? And then starting point, and this is your end point. Okay? Starting point, your end point. Cool. So that's what you learn, and you've learned that Sn of this, if you've given Tn and it start from -1, let's say it ends at, I don't know, 10, this will be the same as T-1 plus T0 plus T1 plus T2 until we have T10. That doesn't look right. Plus T10. Okay, right? And then we've learned about n as your end point minus starting point plus 1. In this case, which is 10 minus -1 plus 1, which you're going to get as 10. Or you can just take your calculator and punch to confirm the numbers, but I don't think it's 10. Actually, it should be 12. Yes, it should be 12, not 10. 10 is wrong. 12. That's your n. That's your n, right? For this video, then we're gonna learn how to go from here to here. Now you're given a sequence, and find now your sigma notation. Find your sigma notation. How we're gonna do that? Let me copy and paste this. So let's say you have this, and then the question is, write this in sigma notation. So the couple of things that you're gonna need on this question. First of all, you need to find your Tn. Right? You need to find your Tn. Second, you need to find your end point. Thirdly, you need to find your starting point. Okay, so let's do that. First thing, your Tn. Now this is the sequence we have. Now firstly, you need to identify if this is an arithmetic sequence or geometric sequence. So now to identify if it's a geometric sequence, you need to check if T2 over T1 is equal to T3 over T2. Now T2 is 6, T1 is 3, T3 is 12, T2 is 6. 6 over 3 is 2, 12 over 6 is 2. Therefore, this is a geometric series, and then R is 2. Cool. R is 2. Now what is A? A is 3. Now we're looking for what? Tn. Remember, I said Tn is a general term. Now this is a series. This is a geometric sequence or series, and this is the general term we're gonna use for general sequencing, right? So if Tn is equal to A R power n minus 1 Tn is equal to A is 3, R is 2, N minus 1. Cool. And this first thing, we've identified our Tn. Second thing now is to find endpoint. Cool. Endpoint. How to find endpoint? Now we go back to our series. We look at the end term. End term is 384. End term is 384. And we have what? Our general term is this. Discover the general term is 3, 2, n minus 1. Right? That's our general term. And that end term is 384. So what we're going to do is we're going to substitute Tn is 384. So 384 is equal to 3, 2n minus 1. Then you can divide it by 3 on both sides. So 384 divided by 3. We're going to have 128. And then on the right hand side, 3 and 2 cancel. So you're going to have 2 power n minus 1. Okay. And then you can find a 2. Right? Okay, so you need to use now what we have learned on our previous video, where the bases are the same. So if the bases are the same, then the exponents are equal, right? So remember, algebra says if you have a power x is equal to a power 2, bases are the same, therefore x is equal to 2. The exponents are equal. So that's what we're going to look for. Bases are the same. Look at the exponents. Exponents are equal, right? So we know that 2 power 7 is 128. So 2 power negative 1. So bases are the same. Then what you're going to do is going to equate the exponent, right? You can should punch in the 2 power 7, you see is 128. Bases are the same now, and then you equate the exponent, and then you solve for n. So you can take this, put the other side, it's going to have 7 plus 1 is equal to n, and then 8 is equal to n. Now this is your what? This is your end term. Cool. Now, how do you calculate our first term? No, the starting point. This is not your end term, we call it the end point rather. Now to calculate the starting point, you take the first term. So starting point, you're gonna say Tn is equal to 3. Now you go back, we have your general term, we calculated our general term as this. Tn is equal to 3 times 2 power n minus 1. So we have 3 times 2 n minus 1. So 3 is equal to 3 to n minus 1. Right? This is our Tn, the first term. We're looking at the starting point. And then from here, you can divide by 3 on both sides. So you can have 1 is equal to 2 power n minus 1. And then we're going to use the same algebra. A power x is equal to a power 2. If the bases are the same, then the exponent are equal. Now, we know that this is the same as 2 power 0. 2 power 0 is 1, right? So it's 2 n minus 1. So the bases are the same, then we equate the exponents. So your n is equal to 1. So what is this? This is your starting point. Nice. So you have your starting point. You have your starting point. Starting point is 1. Your end point is 8. And then your Tn is 3 to n minus 1. Correct. Yes. Okay. Now we can write the sigma notation. Your starting point is 1. Your end point is 8. And your Tn is 3 to n minus 1. And this is your answer. This is cool, right?